Hi, I'm Atul and I'm based in London right now.
Hi, I'm Paul and I'm an A-Level Chemistry tutor based in Burnley, Lancashire right now. Okay, so today we're going to have a look at a bond enthalpy calculation, and it's where we're going to calculate the enthalpy of a nitrogen bond. Now, the first thing to do really with bond enthalpy calculations is to draw the actual bonds. So the displayed formulas rather than the molecular formulas here. So we've got hydrazine, which is told us in the question has an N bond if we weren't sure about the structure of it. And then we've got 4 hydrogens. And it says hydrazine is used as rocket fuel. So we're calculating the nitrogen bond in rocket fuel. And there's our oxygen. And our nitrogen bond, it's in group 5, so it's a triple bond. It's given us the bond in the question, if we weren't sure. And water, we know, is H₂O. So that's 2 hydrogens and 1 oxygen. And then we need to put either draw 2 of them or we can put a big 2 in there. And we're told that the enthalpy change for this reaction is minus 583. So we can write that on the arrow. And then we can work out the bond enthalpies for the reactants and the products. So the nitrogen bond is what we're trying to calculate, so we can call that X. And then we've got nitrogen-hydrogen bonds, 1, 2, 3, 4 nitrogen-hydrogen bonds. So that's 4 times 944. And then we've got an oxygen double bond, which is 498.
NH bond is 388, isn't it?
Thank you, Atul. Where did I get? Oh, I did the nitrogen triple.
Yeah, the triple one.
Yeah, there we go. So NH 388. And then we can add all that up. 4 times 388 plus 498 is 2050 plus X. And then let's have a look at the products. So we've got a nitrogen triple bond, which is 300. Oh, wrong one again.
Yeah, it's the 944.
It's 944. And we've got 1, 2, 3, 4 OH bonds. So that's 4 times 463. And if we add all those up, 944 plus 4 times 463 is 2,796. And there's 2 ways of doing this next bit. You can either remember that to break bonds is endothermic and therefore positive. You've got to put energy in to break bonds. And forming bonds is exothermic. Energy is released when we form bonds. So the forming bonds are more stable. And so if it's exothermic, then that's negative. And the other way of remembering this is it's bonds broken, take bonds formed is equal to the enthalpy change for the reaction. And so this, take this, is equal to the enthalpy change for the reaction, which is 583. And then it's just an algebra equation. So move what's on the left of the equation to the right, we'd end up with x equals minus 583 plus 2796 and minus 2050. So minus 583 plus 2796 and take 2050. Get plus 163 kilojoules per mole. So that's our bond enthalpy for a nitrogen bond in hydrazine, which is used as a rocket fuel.
Right. And I suppose there's a sensibility check. You can also ask. It's a positive number, so a positive number, this implies it's endothermic. For some reason, if it came out to be a negative number, then you could ask the student and check whether do you expect it to be positive or negative. Yeah.
That's a good point. Yeah, if you notice, all the bond enthalpies given here are positive because bond enthalpies are the energy required to break bonds.
And another way I think of just getting I don't know what the answer was going to be for the N single bond, but certainly it feels like it should be less than a N triple bond with another N, because that's there's 3 of them simply as opposed to 1 of them, and so I expect it to be less than the N triple N bond 944.
Yes, it is reasonable compared to the bond enthalpies we've been given as well.
Great, that's a very nice, simple way of doing it. Yeah, look forward to next in this series of enthalpy calculations.
Okay, thanks, Axel.
Great, bye for now.